It's 2009. A man gets home from work and boots up his computer. His name? Marcus Persson, or better known as Notch. Based in Stockholm, Sweden, Persson spends his evenings diving deep into Java code, experimenting with algorithms that would later revolutionize procedural world generation. What he doesn't know is that the file he starts today will change the gaming industry forever, and will make him one of the wealthiest people to ever exist. This is the making of Minecraft. What is perhaps the craziest part of this story is that Notch managed to code the first playable version of Minecraft in just 6 days. Using Java, Notch relied on procedural generation to create an infinite world with simple block-based mechanics. His approach was highly iterative. Each day he added new features and immediately tested them. Although we don't 100% know what exactly happened within those 6 days, this is what is believed to be the breakdown. So it's day 1. Notch lays down the foundation, basic terrain generation using Perlin noise. And in the true nature of Notch, he immediately tested it. This brings us to day 2, where he implements block physics. Players could place and remove blocks. I don't know if it's just me, but the fact that the foundation of what makes Minecraft was done by day 2. That leads us to day 3, where he introduced dynamic lighting and a rudimentary day and night cycle. And then day 4, he improved world rendering and added more block types. Day 5, he developed player movement and collision detection. And finally, on day 6, he finished the first public build and shared it with the community. In just 6 days, the game that changed the lives of millions of people all around the world, including myself, was done. In the very beginning, the game that Persson was creating wasn't even called Minecraft. It was called Ruby Dung, and its technical foundation was built on Java, a choice that would later prove crucial for the game's cross-platform compatibility. While many game developers at the time were using C++ for its raw performance, Persson's decision to use Java would ultimately allow Minecraft to run on virtually any device with a Java virtual machine. This write once, run anywhere philosophy would become instrumental in the game's widespread adoption. So Notch actually had a development blog, and this is how he explained what Minecraft is. It's going to be a fantasy group manager. You don't actually do any quests yourself, but rather assemble, equip, and level up heroes and send them on quests you've gotten from the local town. But beneath this simple concept is complex technical challenges that would shape the future of sandbox gaming. The first technical hurdle that Persson tackled was world representation. He started by implementing a basic terrain generation system using Perlin noise, which is essentially a gradient noise function created by Ken Perlin for the movie Tron. But Perlin noise had a unique property that made it perfect for terrain generation. It could create natural-looking randomness that was both continuous and repeatable. This meant that the same seed value would always generate the same terrain, a feature that would become crucial for Minecraft's shareable worlds. The core of his early prototype relied on a revolutionary approach to world storage. Instead of using traditional height map systems like most games, Persson divided the world into 16 by 16 by 16 cubic chunks. Each chunk was essentially a 3-dimensional array containing block IDs, and this chunking system would later become fundamental to Minecraft's infinite world generation. The genius of this approach, though, was that it allowed the game to load and unload portions of the world dynamically as players moved around, making infinite worlds possible without requiring infinite memory. Persson created a texture atlas, which is essentially one large file containing lots of smaller textures. This wasn't a simple collection of images. It was a carefully optimized system that minimized texture switching during rendering, a significant performance bottleneck in many games. Initially, this atlas only contained 2 textures: grass and cobblestone. But the system was designed to be extensible, allowing for easy addition of new block types without requiring major code changes. Using these elements in his procedural generation system, he created a digital landscape filled with trees. The tree generation itself was one of his first experiments with procedural content generation, using recursive algorithms to create natural-looking structures. Each tree would start with a trunk, and then the branches would spawn recursively with decreasing probability as they got further from the base. This created organic-looking trees that were never quite identical, adding to the game's natural feel. But Persson faced a significant challenge when implementing the first-person view. The pixelated nature of the blocks created unique rendering challenges. At the time, traditional 3D games used smooth meshes with high-resolution textures. but Minecraft's blocky aesthetic required a different approach. He had to develop a custom rendering system that could efficiently handle thousands of cubic faces while still maintaining acceptable performance. During this time, Persson was working as a programmer at Player, the Swedish game developers that would later go on to create Candy Crush. His day job exposed him to various game development techniques, but his bosses at Player were less than supportive when they discovered his new hobby. They almost felt like there was a competing interest and actually barred him from continuing his personal projects. But we all know Notch, and he couldn't be stopped. Rather than comply, he decided to quit his job to continue working on his passion projects. He actually found a new position with the software company J-Album. This is where he befriended the CEO, Carl Manning. J-Album wasn't a game studio, but a company that made digital photo album software. At J-Album, Persson had the freedom to continue his development work, and he began tackling even more complex technical challenges in his spare time. When he shared the first playable version on the TIG Source or TIG Source forum on May 17, 2009, he called it Cave Game. The forum post was simple. This is what it read: Minecraft. It's an alpha version, so there might be some crashes. And that was it. That's all he put. But the technical foundation was anything but simple. The world generation already used multiple layers of noise functions. And instead of going into the nitty-gritty of each one of them, I'm just going to list them out for you. Perlin noise for basic terrain height, simplex noise for cave systems, which is a faster and more modern version of Perlin noise. Also custom algorithms for ore distribution, and last but not least, a sophisticated biome system that could blend different terrain types seamlessly. Almost immediately after posting on the forum, the responses flooded in. And not just that, but they were enthusiastic. One person wrote, "Oh hell, that's pretty cool," within the first 12 minutes, and he was the first responder. One of my favorites is, "I just dig around in the ground a bit, and suddenly I'm in this underground cave. Great sense of exploration already." But honestly, everyone was just really impressed on how the cave systems felt natural and interconnected, which was a direct result of Persson's careful tuning of the noise functions that I listed above that generated them. As time went on, players began to share their screenshots of creations. And thanks to this, Persson felt immense pressure to implement multiplayer support. This would eventually prove to be one of the most technically challenging aspects of Minecraft's development. So what I'm about to list out is everything that the client-server architecture needed to handle. Number 1, efficient chunk streaming to new players joining the world. Number 2, real-time synchronization of block changes across all clients. Number 3, player physics and collision detection. Number 4, entity AI and pathfinding. Number 5, inventory management and crafting. And last but not least, and probably the most important one, is chat and player interaction. So before the multiplayer drop, this is what Persson wrote. Multiplayer will be in the form of a downloadable server, which will broadcast its IP to the main server when it starts up. But like I said, this implementation was far from simple for Persson. He had to develop a custom networking protocol that could handle thousands of block updates while maintaining reasonable bandwidth usage. But his solution was clever. It was a combination of chunk caching and delta updates, only sending changes rather than complete chunk data. With over 300 million sales, Minecraft remains the most sold video game ever made. Its technical environments have influenced countless games, with its approach to procedural generation and voxel rendering becoming industry standards. But the story of Minecraft and its creator, Notch, takes a complex turn that reveals the challenges of sudden success in public scrutiny. In 2017, a series of homophobic and racist tweets led to Microsoft distancing itself from Persson. They removed all the references to him from the game's splash screens and did not invite him to the 10th anniversary celebration of Minecraft. For a game whose technical architecture was built around inclusivity, allowing anyone with a Java-capable device to play, supporting multiplayer across platforms, enabling players to build and create whatever they could imagine, this controversy really hit the gaming community hard. Persson's post-Minecraft life followed a path familiar to many sudden tech billionaires. He moved to Los Angeles. He bought a $70 million mansion in Beverly Hills, noting that he outfitted Beyonce and Jay-Z, and also in that mansion he hosted extravagant parties. But while he mastered the technical challenges of building a revolutionary video game engine, navigating the responsibilities of public influence proved more difficult. The technical legacy of Minecraft persists and grows. Under Microsoft's stewardship, the game has continued to evolve. The development team has added new technical features while maintaining backward compatibility with worlds created more than a decade ago. That is no small feat given the complexity of the game's procedural generation systems. The Education Edition has introduced new generations to basic programming concepts, carrying forward Person's early commitment to making complex technical concepts accessible. So let's get deep here for a second. When is Minecraft the most fun? Is it when you open a new world, watching as the chunk loading algorithm generates fresh terrain, ready for your first build? Or is it when you've mastered its systems, building complex redstone computers and automated farms that push the game to its limits? Mark Person now lives in that second stage of life, having built something revolutionary. He has everything he could ever want. But like many of Minecraft's players, he discovered that the joy often lies in the building, in solving technical challenges, in creating something new. And while many of us who grew up in Minecraft may not have those experiences again, we can't deny that that game was an instrumental part of our childhood and now adulthood. This video in particular was special for us to create, given the impact that Minecraft has had on our lives. So thank you guys so much for watching. If you want to see more videos like this and want to support two former Minecraft nerds, the easiest way to do that is to like and subscribe, and also comment down below with any feedback. Thank you guys so much.